to hold the specimen. Once we set the motor going, the crosshead's going to move in this direction, and so it's going to pull the specimen apart. We've got a load cell here, which is going to measure the maximum load it takes to break your specimen. The machine will measure how much your crosshead moves in this direction, and that'll give you elongation, and then it comes out on your graph as a load extension graph, and then we're going to work out some calculations from there. We've got a little thermocouple at the bottom of the machine attached to this little thing here, and that can blow hot air up onto your sample, so when we start to change the temperatures to 30, 40, 50, 60 degrees, we can change the temperature on here, heat the specimen up. It needs to take a good 5 or 10 minutes for each specimen to get up to temperature. We're going to do this one at room temperature. So all I'm going to do is I'm going to zero the load off and zero the force off to start with. So I'm going to zero the load off, zero the extension off, put it into test mode. All we're going to do now is just start the motor running. Okay, the motor's running. We're starting to put a load on the specimen. Your specimen's starting to elongate. Once it gets to its maximum load, and we've been getting something about 22 or 2300 newtons, it's going to start to neck. Can you see that the specimen's starting to neck in the middle? Once it starts to neck, the cross-sectional area gets less, so the load starts to drop down because of this necking. You can see that it's just starting to neck at that point there. Okay, there it's necking. Hopefully it's not going to neck too much because this is quite a brittle material at room temperature. So you can see that it's necking now. It's elongating a little bit more than I was expecting, but yeah. Okay, so the sample's broken. You can see that there's quite a gap as your sample has sprung back. So when we come to do the elongation, we're actually going to measure the specimen rather than measure off the graph, which is going to be a higher elongation than your sample. So we're printing the graph out now. So what we're going to do is we take the sample out, we're going to put the two samples back together again, and we're going to measure elongation, and then we're going to work out some calculations off the graph once it's printed out. So